Okay. So what is P4 going to be? What are we going to do?
Well, we divide each of these by, so we divide them into lengths of a third.
Okay.
And we have like, we're going to have very small lengths, but we're going to have a lot of them.
That's right. How long is each length going to be?
It's 1/3.
Okay, so we're going to have, each length is going to be 1/3. And the question is, how many are we going to have?
Well,
1/3 times what?
for each of these small lengths, we're going to have 4 of them.
Okay.
And last time, there were 16 small lengths per side.
Right.
So that'll be 16 times 3 times a third.
16, not 16 times 3 times a third.
So we have 16 times...
Each one is a third. So these lengths here get divided into how many pieces?
4.
Okay, they could divide it into 3 pieces, but they turn into 4 pieces. So it's 1/3 times 4 times
16. So that's going to be 64 times a third.
Yep, and then that's just this one side. And then
So that'll be 64.
64. Yeah. Good job. So that's the calculation. So the first perimeter was 27, then 36,
48,
then 48, and then
64.
64. And we want to see if we can see the pattern here. What's going on? Now, you started looking at the differences, which is a good way to do it initially, for sure. So we initially go plus
9,
and then plus
12,
and then plus
16. Yeah.
okay.
So I think I see another pattern. Here plus 3 and plus 4.
Plus 3 and then plus 4. Okay.
I think I see another pattern.
All right, what pattern do you see?
Well, this doesn't work for the first one, but to get from 27 to 36, it does. So you divide the one, so the current one you have, you divide it by 3 and then multiply it by 4.
Aha. You divide by 3 and then multiply by 4.
So that would be 9.
Our idea.
4 is 36.
Right, so that comes right from here. So 3x is going to 4x. So 3 times the first perimeter is going, oh, sorry. I better be careful about what I want to say there. But so we have something, I could divide both sides by 3 here.
Yeah.
And say x becomes 4/3 x.
Yeah.
And then you're starting to notice that I'm dividing by 3 and then multiplying by 4.
So it would work for the next one.
9 times 4 is 36.
And then so that would be 12 times 4 is 48.
Yeah.
And 16 times 4 is 64.
Yeah.
So this seems to be the pattern, and if you keep doing this for infinity, the x just keeps getting larger and larger.
Okay, let's see why. But I want to make sure you both understand here. So sometimes you have these patterns, and we've seen them even recently when we were doing that John Golden find the pattern with echoes. It's so recent, but it's even still sitting right here. With these, we're adding these cubes.
Yeah.
Right. Here we saw a pattern, and we did some differences, and eventually we found a fixed difference that I think was 3 levels down, right?
Yeah.
And that was a neat polynomial pattern, and it involved adding. Here, there's a different pattern, and it involves multiplying. Okay.
Yeah.
And it involves multiplying. So do you see the multiplication here? And it relates to exactly what you wrote down right in the beginning. 3x goes to 4x. So there's a multiplication happening here. So let's see why it now goes to infinity.